solar pond is a large-scale solar collector with an integrated arrangement for storage of heat water. Description: a solar pond is simply a pool of salt water which collects and stores solar thermal energy. The salt water naturally forms a vertical salinity gradient, also known as a Harlock line, in which low salinity water floats on top of high salinity water. The layers of salt solutions increase in concentration with depth. Below a certain depth, the solution has a uniformly high salt concentration. Whenever the water is heated, the hot water is less dense and rises up. So due to the SUNA unregistered trademark S radiation, the hot water in the pond rises up and comes to the surface. The hot water loses the heat gained to the atmosphere. Thus the temperature of the pond remains same as that of the temperature of the atmosphere near it. To prevent this, salt is added to the water to increase the density of the medium so the hot water do not rise to the surface as the density increases and the solar energy is trapped. Advantages and disadvantages: the approach is particularly attractive for rural areas in developing countries. Very large area collectors can be set up for just the cost of the clay or plastic pond liner. The evaporated surface water needs to be constantly replenished. The accumulating salt crystals have to be removed and can be both a valuable byproduct and a maintenance expense. No need of a separate collector for this thermal storage system. Efficiency: the energy obtained is in the form of low-grade heat of 70 to 80 degrees Celsius compared to an assumed 20 degrees Celsius ambient temperature. According to the second law of thermodynamics, the maximum theoretical efficiency of a cycle that uses heat from a high-temperature reservoir at 80 degrees Celsius and has a lower temperature of 20 degrees Celsius is 1 273 plus 20 closing round bracket over opening round bracket 273 plus 80, equals 17%. By comparison, a power plant's heat engine delivering high-grade heat at 800 degrees Celsius would have a maximum theoretical limit of 73% for converting heat into useful work. The low efficiency of solar ponds is usually justified with the argument that the collector, being just a plastic-lined pond, might potentially result in a large-scale system that is of lower overall levelized energy cost than the solar concentrating system. Development: further research is aimed at addressing the problems, such as the development of membrane ponds. These use a thin permeable membrane to separate the layers without allowing salt to pass through. Examples: the largest operating solar pond for electricity generation was the Beit Ha'arava pond built in Israel and operated up until 1988. It had an area of 210,000 m² and gave an electrical output of 5 MW. India was the first Asian country to have established a solar pond in Bhuj, in Gujarat. The project was sanctioned under the National Solar Pond Programme by the Ministry of Non-Conventional Energy Sources in 1987 and completed in 1993 after a sustained collaborative effort by TERI, the Gujarat Energy Development Agency, and the GDDC. The solar pond successfully demonstrated the expediency of the technology by supplying 80,000 litres of hot water daily to the plant. It is designed to supply about 220 lakh kWh of thermal energy annually. The Energy and Resources Institute provided all technical inputs and took up the complete execution of research, development, and demonstration. TERI operated and maintained this facility until 1996 before handing it over to the GDDC. The solar pond functioned effortlessly till the year 2000 when severe financial losses crippled GDDC. Subsequently, the Bhuj earthquake left the Kutch dairy non-functional. The 0.8-acre solar pond powering 20% of Bruce Foods Corporation's operations in El Paso, Texas is the second largest in the U.S. It is also the first ever salt gradient solar pond in the U.S. See also: ocean thermal energy conversion, ice pond, seasonal thermal energy storage, thermal storage, deep lake water cooling, cooling pond, salt evaporation pond. References. External links: the El Paso Solar Pond, University of Texas. Bhuj Solar Pond in India, Tyrian. Israeli unregistered trademark S150 kW Solar Pond, Mother Earth News, June 1980. Research ponds and real-world project at Pyramid Salt, Pyramid Hill, Northern Victoria, AU, Royal Melbourne Institute of Technology.